Have you ever gazed at a picture of Jupiter and just been mesmerized? It's this colossal, swirling marble of gas, painted with the most incredible stripes of white, fiery red, burnt orange, and deep brown. It's beautiful, but it's also one of the biggest, most colorful mysteries in our solar system. What gives Jupiter its stripes? Why these specific colors? Well, buckle up, because we're diving deep into the vibrant and enigmatic atmosphere of the gas giant. For centuries, astronomers have pointed their telescopes at Jupiter, charting its storms and its famous bands. These bands, known as zones and belts, circle the entire planet. The lighter colored bands are called zones, and the darker ones are called belts. We know they're not just surface paint. They're massive jet streams of gas, flowing in opposite directions at mind-boggling speeds, some reaching over 300 miles per hour. The zones are areas of rising gas, while the belts are areas of falling gas. This up and down motion, this giant atmospheric conveyor belt, is fundamental to Jupiter's weather. But that explains the motion, not the color. Why are the rising zones a creamy white, and the falling belts a rich tapestry of reds and browns? The simple answer, and the one that drives scientists crazy, is that we don't know for sure. It's a genuine cosmic whodunit. The leading theory is that the colors are the result of complex chemical reactions happening high up in Jupiter's atmosphere. Think of it like a giant planetary-scale chemistry lab. The primary ingredients we know are hydrogen and helium, which make up most of the planet. But those are colorless gases. The color must come from trace elements, the tiny spices in Jupiter's atmospheric soup. Scientists suspect that compounds containing sulfur, phosphorus, and carbon are the key players. These elements, churned up from deeper, hotter layers of the atmosphere, get zapped by the sun's intense ultraviolet radiation. This UV light acts like a catalyst, breaking these compounds apart and forcing them to recombine into new, more complex molecules called chromophores. Chromophore literally means color bearer. These are the molecules that are believed to be responsible for staining the clouds. Let's talk about the specific colors. The brilliant white and pale yellow colors of the zones are probably the easiest to explain. These are thought to be clouds of frozen ammonia ice. As gas rises in the zones, it gets colder, and the ammonia condenses into bright, reflective ice crystals. Just like how water vapor forms white clouds here on Earth. So, when you see a white band on Jupiter, you're likely looking at the frosty tops of towering ammonia clouds. But then we get to the reds, oranges, and browns of the belts. This is where the real mystery deepens. The Great Red Spot, Jupiter's most famous feature, is the ultimate example. It's a storm that has been raging for at least 350 years, and its color has puzzled us for just as long. One popular idea is that some unknown chemical, let's call it chromophore X, is dredged up from deep within the planet by the powerful storm. When it reaches the upper atmosphere, it gets blasted by UV sunlight and turns red. What could this chromophore X be? There are a few suspects. Some scientists point to sulfur compounds. Different forms of sulfur, called allotropes, can create a whole palette of colors, from yellow to red to brown, depending on the temperature and pressure. It's possible that as gas sinks in the belts, the changing conditions create these colorful sulfur molecules. Another candidate is complex organic molecules called tholins, which form when UV light hits simple carbon-based compounds like methane. Lab experiments show that tholins can produce a reddish-brown gunk, similar in color to Jupiter's belts. The problem is, we can't be sure. The Juno mission, which is currently orbiting Jupiter, has given us the most detailed look at the planet ever. It has instruments that can peer deep beneath the cloud tops, measuring temperature, composition, and gravity. Juno has revealed that Jupiter's weather systems, including these belts and zones, extend far deeper into the atmosphere than we ever imagined, hundreds, maybe thousands of kilometers down. This suggests the processes creating the colors are incredibly complex and tied to the very heart of the planet. However, Even with Juno's powerful sensors, identifying the exact chemical compounds responsible for the color is incredibly difficult from orbit. The chromophores are likely present in only tiny amounts, parts per billion, mixed into the vast sea of hydrogen and helium. It's like trying to identify one specific grain of colored sand on an entire beach from a helicopter. To really solve this mystery, we would ideally need to send a probe directly into Jupiter's atmosphere, one that could sample the clouds of a belt in a zone and analyze them on the spot. We've done this once before, with the Galileo probe in 1995, but it happened to enter an unusually dry, clear spot, a hot spot, and didn't give us the data we needed on the colorful clouds. A future mission, designed specifically to sniff out these chromophores, would be the ultimate dream for planetary scientists. It's also fascinating to think about how altitude plays a role. It's possible we're seeing different colors because we're looking at different layers of clouds. The white ammonia clouds might be the highest deck. Beneath them could be a layer of brownish ammonium hydrosulfide clouds, and perhaps even a deeper, unseen layer of water clouds. The belts, being areas of sinking, clear air, might simply be allowing us to peer deeper, to see these lower, more colorful cloud decks, while the zones are obscured by the high white ammonia clouds. So, in essence, Jupiter's vibrant bands are a beautiful visual representation of a massive, dynamic weather engine. The colors are clues, breadcrumbs left by unknown chemical reactions powered by sunlight and the planet's internal heat. They hint at a complex interplay of sulfur, phosphorus, and carbon chemistry. But the exact recipe remains tantalizingly out of reach. Every new image from Juno, or the James Webb Space Telescope, gives us another piece of the puzzle. We see the colors shift and change over time. Storms merge, belts fade, and zones widen. It's a living, breathing world, and its colors are telling a story that we're only just beginning to learn how to read. The mystery of Jupiter's colors isn't just a question of planetary science. It's a reminder that even in our own solar system, there are fundamental secrets waiting to be discovered. It's what keeps us exploring, keeps us looking up, and keeps us asking why. Thank you so much for joining me on this journey to the heart of a gas giant. It's truly amazing to think about the cosmic chemistry painting such a masterpiece across our night sky. If you found this as fascinating as I do, please hit that like button and consider subscribing for more deep dives into the mysteries of our universe. And don't forget to click the notification bell so you won't miss our next adventure. Thanks for watching.